Okay, so if you've ever written a line of code, I guarantee you've heard this mantra. DRY. Don't repeat yourself. It's one of the first rules we're taught, and it promises us this beautiful world of clean, easy-to-manage code. But what if I told you that this very principle, when we get it wrong, is actually the secret ingredient in the recipe for a codebase that's impossible to change? Yeah, let's dig into that.
We have all been there. You crack open a project for the first time, and it's just a total mess. You know that feeling, where making one tiny little change feels like you're playing a game of Jenga during an earthquake? So where does all that chaos actually come from? I once heard a developer call this a rat's nest, and I think that's just perfect. It's this system where every single thing is so tightly wound and tangled together that you're literally afraid to touch anything, because you have no idea what's going to break. This is the exact pain point we are all desperately trying to avoid. And then, into this mess, rides our hero on a white horse. The dry R principle. Don't repeat yourself. The idea seems so simple, right? Find code that's been copied and pasted, stick it in one central place, and you're done. It feels like the perfect, elegant solution to all our problems.
So let's walk through how this usually plays out in the real world. This is what I'd call DRY 101. It's the version that pretty much every single developer learns right at the beginning.
So picture this. You've got three simple web pages, a home page, an about page, a contact page. And on every single one, the HTML for the header and the footer has been literally copied and pasted. Now your boss comes over and says, hey, we need a new link in the header. Ugh, now you have to go hunt it down and change it in 3 different files. It's just asking for trouble.
The fix seems pretty obvious, doesn't it? You take that chunk of repeated header code, you pull it out into its own function, we'll call it print_header. You do the exact same thing for the footer with print_footer. Then you just go back to your 3 pages and replace those big, messy blocks of code with a nice, clean, single function call.
And boom, just like that, the code is way cleaner, it's easier to read, and it's actually maintainable. Now when your boss asks for another change, you only have to edit one single file. Beautiful.
So problem solved. We did it. Our code is now dry. But hold on a second. Is that really the whole story? I mean, if it were really this simple, why do so many code bases that are supposedly dry still end up as those tangled messes we all dread?
And this is where we get to the absolute core of it. The single biggest misunderstanding about dry is that it's just about hunting down duplicate lines of code. The real idea is so much deeper than that.
Let's go back to the source. The book that actually introduced this principle, the Pragmatic Programmer, defined it like this. Now pay close attention to the word they use, knowledge. They don't say code. The real goal here is to avoid repeating knowledge, the fundamental business rules and concepts that your system is built on.
So here's the best way to think about it. Repeated lines of code are just a symptom. The actual disease is when you have multiple sources of truth for a single piece of business knowledge. If the rule for how to calculate sales tax lives in 5 different places in your system, that's the real problem, and it doesn't matter if the code in each of those places looks a little bit different.
And you know, this idea of knowledge is everywhere. It's not just in the code itself. It's repeating business logic in your front end and your back end. It's repeating a bunch of manual steps to deploy your app instead of just automating it. Heck, it's even storing the exact same customer address in 3 different database tables. Dry applies to all of it. All right, so what happens when we ignore all that and just focus on the symptom, on just getting rid of similar-looking code? Well, this is where a well-intentioned principle can actually become pretty dangerous.
See, when you start aggressively combining any code that just looks the same, you create something called tight coupling. You're basically shackling totally unrelated parts of your system together. So now, a change over here in, say, the billing module can cause this unexpected ripple effect that breaks something in the shipping module. Your code becomes fragile, rigid, brittle.
And the hidden costs of this are huge. You end up creating abstractions way too early before you really get what the pattern is. You kill your system's flexibility because now 2 things that really should change independently are stuck together. And honestly, it just makes the code a nightmare to understand. It creates so much cognitive overload trying to figure out what a change will actually do.
Here is the perfect example. Imagine you're building a logistics system. You have a concept of a vehicle. Okay, fine. But is the vehicle you need for dispatching an order, where you might only care about its ID and current location, the same concept as the vehicle for unhooking a trailer, where you care about totally different things like its hitch type? No. They just happen to share the same name. Forcing them both into one giant, shared vehicle object is a classic DRI mistake.
So, if blindly stamping out all duplication is a trap, what's the right way to do this? Well, it's not about memorizing a rule. It's about developing good judgment. It's an art of balance. Here's a fantastic little heuristic that a ton of experienced engineers swear by. It's called the rule of three. The first time you write a piece of logic, just write it. The second time you find yourself writing the same thing, you'll feel that itch to abstract it. Resist. Only when you are about to write it for the third time should you even start to think about creating a shared abstraction. And before you do, you have to ask yourself these critical questions. 1. Is this code actually representing the exact same business concept, or does it just look similar? 2. If I change the logic for one of these, will I always, without fail, have to change it for the other? And 3. Is this pattern actually stable, or is it likely that these two things will need to evolve differently over time? If you can't say a big yes to all three, step away from the abstraction.
And it's so important to remember that DRI doesn't exist in a bubble. It has to be balanced against other really important principles. You've got KISS, keep it simple stupid, which warns us about getting too clever with our abstractions. You've got YAGNI, you ain't gonna need it, which stops us from building things we don't need right now. And my personal favorite, AHA, avoid hasty abstractions, which is like a direct antidote to misusing DRI.
So in the end, you're always making a trade-off. If you have too little dry, sure, you risk bugs and inconsistencies. But if you have too much dry, you risk a system that's a tangled mess of complexity and is too rigid to change with the business. The goal is not zero duplication. The goal is to find that strategic sweet spot right in the middle.
And this is the nugget of wisdom that every senior developer eventually learns, usually the hard way. A little bit of duplicated code is so much easier and so much cheaper to deal with than a fundamentally wrong abstraction that has its tentacles wrapped around your entire system.
So the next time you see some repeated lines of code, I want you to stop. Take a breath. The question you should be asking yourself isn't, is this code repeated? The real, pro-level question is tolerating this duplication right here, right now, a cheaper and better decision than creating what might be the wrong abstraction? When you start asking that question, you'll know you're finally using DRI correctly.